This video is intended to demonstrate the cleanability of twisted tube technology on both the shell side and the tube side. The first example shows one of a series of 16-inch diameter hairpins cooling compressed sour gas with poor quality cooling water, which were having performance problems due to shell side fouling. One of the new twisted tube bundles was extracted after 10 months to evaluate its condition and its ability to be cleaned. The performance was still going strong at the time. The bundle has been extracted from the shell and the shroud removed. When properly aligned with the lanes between the twists, the water jet can be seen penetrating through the bundle even though it is a triangular layout. It can also be observed that the hydroblast deflects and exits the bundle in different direction when hitting a contact point between the tubes. This particular bundle was cleaned with a handheld water jet which operated at 3000 psi as shown by the operator leaning against the force of the spray. Once finished, a lamp was located on the opposite side of the bundle to demonstrate how effective the cleaning had been. The next bundle was sent to brown fin tube for retubing and arrived badly fouled on both the shell side and the tube side, which presented us with the opportunity to try hydroblasting a large diameter bundle. The primary objective was to hydroblast the shell side of the bundle, then cut and remove half the tubes and evaluate the effectiveness of the cleaning. As you will see, a few tubes were cleaned on the tube side as well. The initial effort was using a rotating nozzle with two jets. Although this was effective in cleaning the outer rows of tubes, there was a concern regarding how well the interior of the bundle was being cleaned. When switched to a single nozzle and care taken in lining the single blast with the lanes between the tubes, the water can be clearly seen penetrating through this large bundle. This setup was repeated from 6 directions, each 60 degrees apart, thus ensuring the blasting was directed at each of the 3 lanes from each side. This bundle contains 2,918 tubes of 3/4 inch diameter. It replaced a conventional shell and tube with 2004 tubes and offered this customer 45% more area with a lower shell side pressure drop and complete elimination of vibration. The same can be observed from the opposite angle. Note the tracking system for the rig and how the twisted tube bundle remains even though it is supported by each of the tube sheets. The rig was rated for 60 gallons per minute at 10,000 psig. A sample of tubes was also cleaned, with the setup being used that day for the U-tubes with the flexible lance. The tip used is designed to blast back as well as forward, which helps to pull the lance down the tubes. The operator inserts the end of the lance in the tube and increases the pressure. The tube side was cleaned with the same rig at 10,000 psi, and the tubes cleaned were marked so that they could be identified when the bundle was cut open. When the bundle was cut open, a sample of clean tube and a fouled tube were sliced lengthwise. The tube side was obviously badly fouled, and the hydroblast did clean the entire inside diameter of the twisted tube. As the bundle was to be retubed, half the tubes were cut close to each tube sheet and removed. This presented a unique view of the cross-section of the bundle showing the entire diameter. The view shows the tube-to-tube contact support and tubes being cleaned effectively in the interior as well as the exterior. The final twisted tube bundle had been in crude oil to heavy vacuum gas oil service for 18 months and was cleaned during a turnaround along with many conventional shell and tube bundles. The gas oil was on the shell side. The fouling was uniformly distributed over the tubes. Twisted tube bundles are rugged and can be picked up with slings at any location. This bundle was lifted by its lower shroud, placed on rollers, and rotated to allow for the shroud to be lifted off. This bundle was cleaned by hydroblasting with a double nozzle mounted on a boom mechanism, which permitted the operator to adjust the position. The cleaning may have been more effective in this case by moving the nozzles closer to the bundle itself. It should also be pointed out that any type of cleaning in place technology will be more effective in twisted tube than conventional shell and tube. This is due to the tube side swirl flow as well as the baffle-free construction of our bundles. With the multitude of contact points, the water jet will sometimes deflect when hitting these points as shown by the jet exiting in different directions. For additional information on twisted tube technology or other brown fin tube products, please contact your local representative or visit www.brownfintube.com.